Hello everyone, welcome to the course of Ultrasonic Testing Technology. The main content of this course is coupling and compensation in the process of ultrasonic testing. Through the study of this lesson, I hope to achieve the following teaching objectives. Master the meaning and use significance of coupling agents. Master the types and characteristics of common couplings. Master the factors affecting the acoustic coupling effect. Master the coupling loss and its measurement method. First, what is the coupling agent? It refers to a layer of sound transmitting medium applied between the workpiece surface and the ultrasonic probe during the ultrasonic testing. Through coupling, the ultrasonic wave can smoothly propagate into the inspected workpiece. So why do we need to use couplings in ultrasonic flow dictation? The reason is that during the ultrasonic flow dictation, there is an air gap between the probe and the workpiece dictation surface, forming a solid GAS interface based on the characteristics of ultrasonic propagation in the medium. The ultrasonic wave will be almost all reflected at this interface and cannot be transmitted into the workpiece to be inspected. So it is impossible to perform ultrasonic detection on the workpiece. In order to make the ultrasonic wave smoothly transmitted into the workpiece to be inspected, a sound permeable coupling medium needs to be applied between the ultrasonic probe and the workpiece dictation and surface to exclude the air there between to form a solid gas interface, so as to increase the sound intensity transmittance. Secondly, the existence of the coupling agent can reduce the friction between the probe surface and the workpiece surface, so that the probe can flexibly slide on the workpiece for exploration, and at the same time, it can protect the probe and extend the surface life of the probe. Through the above description, we understand that the ultrasonic inspection of workpiece needs coupling effect to be successfully completed. Similarly, our classroom teaching also needs coupling effect to achieve twice the result with half of the effort. Teaching and learning should be a complementary system. Teachers and students, as constituent elements in the teaching process, need to promote the coupling of teaching and learning by speaking, asking, answering, and correcting, together to improve the quality and effect of teaching. Therefore, I hope that the students will listen attentively to the lecture in this course, carefully analyze the classroom questions reserved by the teacher on mooc.com after class, and answer them completely. Finally, they will watch the teacher's review and error corrections analysis in time. Now, let's learn what can be used as couplings and what are their characteristics. There are many kinds of couplings commonly used. For example, water. Water is often used in water immersion ultrasonic flow dictation as a coupling agent. It is characterized by the most easily obtained, low press and good wettability, but it required a high degree of cleanliness on the surface of the workpiece, and is easily to lead to corrosion of iron-based metal workpiece. Engine oil. As the coupling agent, engine oil is characterized by relatively low press, convenient purchase, low corrosion of metal workpiece, protection, and low harm operators. Therefore, it is one of the most widely used coupling agents, mostly used for ultrasonic testing of general rough surface and machined parts. Glycerol, that is glycerol. This is a coupling medium with good sound transmission effect and is insensitive to acoustic contact pressure, which is suitable for workpieces with high surface finish. The disadvantage is that the price is high and the water absorption is strong. After absorbing the moisture in the air, the concentration and viscosity will change, thus change the coupling performance. Water glass, whose chemical name is sodium silicate, Water glass also has a good sound transmission effect and is cheaper, but it has the same characteristics of strong water absorption as clear silicon. Spatial ultrasonic testing couplant. It is an ultrasonic testing couplant specially prepared by comprehensively considering the requirements of sound permeability, wettability, versatility, etc. required by the couplant. The coupling effect is good, but the price is high. Chemical paste. This is a food additive refined from starch. It can be mixed with tap water in a ratio of about 1 to 10 to form an industrial glue as the coupling agent for ultrasonic testing. It is suitable for workpiece with rough surface. It has no corrosion of workpiece and is harmless to human beings. However, since it adheres to the surface of workpiece after drying, it will affect the appearance of workpiece and subsequent surface treatment, so it needs to be washed with clean water in time after testing. High temperature couplant. Most commonly used ultrasonic couplants will evaporate rapidly if they are used hot surface above 100 degrees centigrade. Therefore, ultrasonic testing at high temperature requires the use of special formulated couplants, which can maintain stable liquid or paste at high temperatures and have good thermal insulation performance. The above is the coupling medium commonly used in non-destructive testing. The specific coupling medium to be used as the coupling agent in flaw detection needs to be comprehensively considered according to the material, surface condition, and a subsequent processing process of the workpiece. In the process of ultrasonic flaw detection, the effect of acoustic coupling is different, which will directly or indirectly affect the flaw detection result. Which are the factors that affect the acoustic coupling effect? The first is the type of coupling agent. When selecting coupling agent, the following requirements should be considered: high acoustic impedance and good sound transmission performance. It has low corrosion to the workpiece, is harmless to human body, and does not pollute the environment. It can wet the surface of workpiece and probe with proper fluidity, viscosity, and adhesion, and easy to clean. Stable performance, not easy to deteriorate. Wide source and low price. In terms of the thickness of the coupling layer, when the thickness of the coupling agent is all the times of the half wavelength, the sound transmission effect is poor. The ultrasonic energy entering the workpiece is weak, and the reflected echo of the effect is low. When the thickness of the coupling agent is even times of the half of wavelength or very thin, the sound transmission effect is good and the reflected echo is high. From the perspective of workpiece surface roughness, the rougher the workpiece surface, the worse the coupling effect and the lower the reflected echo. However, on the contrary, the smoother the workpiece surface is, the better, because too smooth will increase the absorption force between the probe and the workpiece, and it will be difficult to move the probe. According to the provisions of Forging Flaw Dictate in the Non-Destructive Testing Standard of Pressure Equipment NB T4701-32015, the surface roughness RA shall be less than 6.3 UN. From the surface shape of the workpiece, the bottom of the commonly used probe is flat. If the surface shape to the workpiece is different, the acoustic coupling effect is also different. Among them, the planar coupling effect is the best. The convex surface is the second, and the concave surface is the worst. Now, let's learn what is coupling loss. It means that in actual detection, when the surface roughness and the curvature radius of the test block used to adjust the detect sensitivity are different from those of the workpiece to be tested. The actual sensitivity and the adjustment sensitivity are often consistent when detecting the workpiece. This phenomenon is called coupling loss. In general, the surface of the inspected workpiece is rougher than the surface of the test block used to adjust the sensitivity, and the return height of the defect is low. Therefore, if no measures are taken to offset the coupling loss, the quantitative result of the defect will be too small. How to determine the coupling loss? In general, the method for measuring the coupling loss difference is to prepare a reference test block, whose surface coupling state is different from that of the workpiece to be inspected, and measure the echo dB difference between them under the same other conditions. Here, there should be two situations. When the thickness of the reference block equals the thickness of the workpiece, the measurement method 1 is applicable. That is, the same cross-hole reflector is persisted at the same depth of the test block and the workpiece respectively, and then the probe is placed on the test block and the workpiece respectively to measure the cross-hole's echo, so as to obtain the echo height difference between the two delta dB. This delta dB is coupling loss difference between them, as you can see. When the thickness of the workpiece and the thickness of the test block are not the same, the measurement method 2 is applicable to keep the workpiece and the test block in the same bottom state. This method can be divided into two cases. When the thickness of the workpiece is less than the test block, suppose that the echo height corresponding to 1 time of the span on the workpiece is h1. The echo height corresponding to 2 times of the span is h2, and the echo height corresponding to 1 time of the span on the test block is h. Measure the height difference between h and the connection line of h1 and h2 with Peake's delta dB, that is, the coupling loss difference between them. When the thickness of the workpiece is larger than the test block, suppose that the echo height corresponding to 1 time of the span on the test block is h1. The echo height corresponding of 2 times of the span is h2, and the echo height corresponding to 1 time of the span on the workpiece is h. Measure the height difference between h and the connecting line of h1 and h2 Peake's delta dB, that is, the coupling loss difference between them. After the coupling loss value is measured, in order to offset the difference in dictation sensitivity caused by the coupling loss, it is necessary to compensate the coupling loss. The compensation operation is carried out after dictation sensitivity is adjusted and before scanning the workpiece. Okay, that's all for this class. See you next time.